A very good morning to all of you. Now this is in continuation to what we had done in the last TPS activity, that is the enthalpy content. Now let's get into much deeper aspects of this, that is in order to refine and revise the basic concepts of enthalpy and what gets into estimation of enthalpy content. I am Dr. Lakshmi presenting the estimation of enthalpy content. Now, before we get into the broad intricacies of this topic, let's understand what is enthalpy. It is the heat content of a substance. It can also be considered as the total energy of a substance. Whenever there is a physical or a chemical process that occurs, there is heat which usually is given out or absorbed from the surroundings. The thermodynamic definition of this enthalpy H is equal to the energy of the system and the product of the pressure and the volume, which is nothing but the work done on the system. Now, enthalpy, which is the heat content, that changes for the varied processes, and these changes are associated with different kinds of changes which are taking around us. It could be the enthalpy which is associated with the change of temperature at a constant pressure. It could be change of pressure at a constant temperature. It could be associated with any kind of a change of phase, like liquid to solid or solid to liquid. Preparation of solutions. Enthalpy changes associated with mixing. Enthalpy changes which are associated or involved in chemical reactions, and finally the enthalpy changes which are associated with crystallization. As we had earlier discussed, now let's recall what is the original definition of enthalpy. The thermodynamic definition says that enthalpy is nothing but the energy plus the work done. Now then, for a change in enthalpy at a constant pressure, what do we have is enthalpy change is nothing but equal to the heat transferred at a constant pressure. Now, having discussed the various kinds of enthalpy changes which are associated with varied types of changes that occur, let's now focus on what happens in a chemical reaction and how do we calculate the enthalpy change. It includes the enthalpy of the product. It is basically the difference of the enthalpy of the product and that of the reactants. If this del H is less than 0, then the reaction is said to be exothermic. Likewise, if the del H or the enthalpy difference is greater than 0, then the reaction is endothermic. It means, rather in practical scenario, it indicates that the heat goes from the surroundings into the system. For more in-depth examples of such exothermic reactions, you can watch the site which is available. Now, having understood this, let's get into the Hess's law and the many pathways of which are associated with enthalpy. It indicates that the enthalpy which is there is a state function, and the enthalpy change for a process is independent of the pathway. The Hess's law states that the overall enthalpy change for a reaction equals the sum of the enthalpy changes for individual steps. Now coming to yet another aspect of enthalpy change, which is associated with a phase change, that is the fusion. It is defined as the heat that is absorbed when the melting occurs at a constant pressure. If the substance freezes, the reaction is reversed and an equal amount of heat is given off to the surroundings. Then the enthalpy, which is the enthalpy associated with melting or fusion, is given as the heat content of the liquid minus the heat content of the solid. Now, having dealt with so many terms associated with heat, let's now understand how is the heat capacity estimated. This heat capacity is an extensive property, and hence this is associated with the quantity of the material which is available. The heat content or the heat capacity is given as the heat absorbed by a system divided by the increase in temperature. Now Let's look into yet another definition which includes the specific heat capacity. It is the quantity of heat required to raise the temperature of 1 gram of substance by 1 degree centigrade. The enthalpy content is associated with this specific heat capacity, and it is the product of the difference of temperature and the mass. Now, molar heat capacity is the energy which is associated to raise the temperature of 1 mole of a substance by 1 degree centigrade. Now, let's get into yet another mathematical basis which we had done as a TPS activity, which includes, that is, the estimation of enthalpy content of the food samples. Now, the food samples around us could be fat-free or they may be containing fat. Now, if it is a fat-free material, then the specific heat capacity of the food samples is estimated using an average of which is equal to the specific heat capacity of and multiplied with the mass fraction of water and a summation of the specific heat capacity of the non-fat solids and their mass fraction. Like this specific heat capacity which is estimated from here is utilized in order to determine the enthalpy content. Now, coming to the fat containing material, we would care that since this fat containing material may have other essential components like the proteins, fats, and carbohydrates, and they could be crude fiber, any of them, then the specific heat capacity or the average specific heat capacity is estimated using a summation of the products of each of these individual specific heat capacities with the respective mass fractions. Now, there's a small quiz based on the concepts which we have learned. Try to just check out whether you are able to solve these or not. And thank you.